Greetings, everyone. This is Dr. Jess Armine, and in response to my query to everybody about pH, I decided to take the PowerPoint presentation and create a short video to demonstrate the importance of this particular concept. Anyone who needs to ask questions or get in touch with me can go to my website as noted there, or call us at the 267 number. Also, I would like to acknowledge Bill Downs, who is a nutritional biochemist, who is the creator of Protovite, Brain Reward, and many other substances. He is the creator of the PowerPoint that we're presently using, and I'm using this with his kind permission. And I just thought it was a great way of looking at pH. The pH picture. Maintaining a healthy pH in your body is one of the most important functions in your body. If your pH moves 0.3 of a point, life's game is over, which means we're supposed to be at 7.4, 7.4, 7.5, 7.6, death, 7.4, 7.3, 7.2, 7.1, death. Okay, so your body's going to really work hard to maintain the pH that it's supposed to be at, because that's how all of our bodily functions work, in a certain narrow range of pH, okay, which is acidity or alkalinity, by the way, okay, and a certain temperature. Obviously, if our core temperature gets below a certain point, nothing works. That's kind of what differentiates us from fish. Fish have to get their temperature and everything from the environment, so once it gets down to a certain point, their biochemical activities just simply don't work. We are independent of that, so we create our own heat, and we have to maintain our own pH. It's so critical that if it's threatened, the body will go to really excessive lengths to correct the imbalances by stealing buffers from non-critical tissues. And guess what? It'll steal it from muscle tissue, from other tissues, and then when it can't get it from anywhere else, it's going to get it from the bones. So that's one of the biggest reasons for osteoporosis, by the way. Okay, eventually, like I said, it gets to the bone, and then it will continue to just keep taking the buffers out and to balance the pH, okay, to maintain this narrow range so that our biochemical processes will continue to work properly. So this is what we're really looking at. 7.0 is neutral. When you go above 7, you are more alkaline. When you go below 7, you're more acidic. What that really means is that when you're acidic, you have more just simply hydrogen ions. When you're more basic or more alkaline, you have hydroxyl groups, which are the OHs. Okay, we're supposed to be at 7.4, okay? And like I said, concentration of H's, acid, concentration of OHs, alkaline, okay? The difference is anaerobic activity, or anaerobic respiration, or anaerobic functions. It takes place whether it's actually alkaline or acidic, but basically it will work in the acidic environment, where aerobic respiration works with oxygen. Why is that important? Well, it's inefficient, the metabolism done anaerobically, and it's more efficient because what happens, to get your energy, you need oxygen. So what happens is during glycolysis, okay, glycolysis, and the products go into the Krebs cycle, and the Krebs cycle have their products go into the mitochondria. But if you don't have oxygen, the products of glycolysis, which is the first step, will not go into the Krebs cycle. So here's the way it's supposed to work. It's about 1 mole of glucose is supposed to give you 38 ATPs, which is your energy. Okay, so glycolysis gives you 2 ATPs, whereas the results of the Krebs cycle, which is the aerobic side, and the mitochondrial function give you the other 36 ATPs. Okay, therefore, if your pH is on the acidic side, you're going to have to use 19 times the amount of glucose in order to get the same amount of ATP. Okay, and glycolysis will just continue. It's a mechanical process. It will just continue and continue and continue. So here's the difference. Like I said, 1 glucose will give you 2 ATP molecules, whereas 1 mole of glucose, which is a number, of course, it's not a furry animal. Okay, 1 glucose, if you're going to get into oxidative respiration, will give you 38 ATP molecules. So what's the big deal, right? Well, guess what? If you have to utilize just your glycolysis, you're going to have to use a whole lot more sugar to get your 38 ATPs. And lactic acid, which is part of the production from glycolysis, the lactic and pyruvic acid, promotes cell damage. And also, sugar is acid promoting, and anaerobes like yeast, fungus, molds, parasites, worms, bacteria, cancer, all the creatures of decay love that environment. They don't want you to have an aerobic environment. It kind of makes you think, are the yeast and everything telling you what to eat or telling you how to act? There's kind of evidence coming out now that says that might be true. Whereas, if you have the adequate amount of buffers, you can maintain an alkaline pH. And let me tell you something, that's the point I was trying to make. Everybody's talking about pH of the stomach and pH of the this and that, and they're all valid points. But the real valid point, the absolute valid point, the thing that you really need to know is that to maintain an alkaline pH, and we're not talking about majorly alkaline, an alkaline pH, you need buffers. So how pH works. There's a couple of different kind of buffers. Outside the cells, we use breathing and our kidney function, okay, to regulate carbonic acid, all right, in this manner where if you're breathing out a lot of carbon dioxide, you can move that equation back and forth. Okay, so that's one way of maintaining pH. Okay, the second way is inside the cells, where we actually use our hemoglobin, which is about 20% of our cell buffering capacity. Okay, so sometimes when I'm doing a live blood cell analysis, you can see the red blood cells and they seem a little attenuated in the inside, and you say to yourself, gee, that person probably is acidic because their hemoglobin is being pulled out to be utilized as a buffer. Okay, now the real buffers that we need, that we're looking for, are things like calcium, magnesium, sodium, potassium, okay, and phosphate and chloride are the main buffers. Now, not sodium bicarbonate, not potassium bicarbonate, okay, or calcium carbonate. It's calcium, magnesium, potassium, sodium, chloride, and phosphate are the main buffers. In other words, your trace minerals. That's what your body's looking for to maintain your buffering capacity and keep you on the alkaline side. Okay? So mineral deficiencies, now we'll talk minerals, strain your buffering capacities, promote acidosis, and impair glucose metabolism and strain the kidney. It's kind of nasty, and it's a thing that if you just remember that you need buffers, you need these minerals, this is something that's really, really easy to treat, okay, and can affect your entire energy metabolism, your entire physiology, okay, and homeostatic compensation. Deficiencies like this promote mineral theft from other compartments in the body. So since it's so critical, the body will cannibalize itself to get the buffers. Okay, so think about it. All right, all you have to do, remember, I always talk about foundational work. Okay, foundational work is exactly that, building the foundation. And I think the whole world's making it a little bit too complicated. It doesn't have to be. Okay, you have the idea already about getting vitamins and minerals into the cells. Well, if that makes sense, the cofactors and coenzymes, right? But if you look at the biochemical pathways, you also need various minerals. Well, this is another reason that you need minerals, okay, to maintain your pH on the alkaline side so that your entire energy system works, the way it's supposed to. It's very basic. If you don't do this, you end up doing a whole mess of other things, coenzyme Q10, all of this all over the place, where all you really need to do is to make sure you get vitamins and minerals into the cells, and especially make sure you have enough, and I don't think you can get too much of it, of the buffers that you need. So, it's not that hard. Okay, so anyway, some of the signs of mineral deficiency, okay? Not all of them, okay? But if you have this, plus you tend to be on the acidic side, guess what? This is one of the things that you can actually take care of. So here's the takeaway from this little video that I'm going to release, and I know that I'm being very jovial and stuff like that, but it's really that simple. Here's what I want you to know. It's important to maintain an alkaline pH. Why? Because it allows your energy system to work the way that it's supposed to, work in an efficient manner. It actually makes you healthier to do that. 2, how do you maintain an alkaline pH? The simplest, the basic, the way it's supposed to be done is to make sure you have adequate absorbable buffers, calcium, magnesium, so forth and so on, as we just said. okay? So that your body stops stealing from itself, okay? And that you have the minerals available not only for your biochemical processes, but to lean you towards the alkaline side, okay? Alkalinity makes you healthier. If you're acidic, you're feeding the bugs. You're feeding candida. You're feeding the parasites. If you allow yourself to stay over there, that's what will happen. If you allow yourself to become more alkaline by the simple modality of making sure you have enough buffers, you will make the environment healthier and you will make the environment inhospitable for those bugs and they will die. Okay? This is the whole thing about foundational work. We all tend to make it a bit too complex. So this video is done for my friends on Facebook and everywhere else. Okay, it's done for lay people, and I've already told you what the takeaway points are. So guess what? All right, how do you get the minerals? Loads of different ways. Okay, you want to make sure they're absorbable. Things like fulvic acid minerals you can get off the internet. Okay, things like multi-mineral citrate malate compounds if you happen to have some oxalate issues. Okay, but you need a good, and depends on the vitamin that you're taking, a good absorbable form of minerals. Okay, so I hope I got the point across. If I haven't mentioned every single thing about 6 or 7 times, this is Dr. Jess Armine, and I hope you enjoyed this little video. Bye-bye.